Hello guys, welcome to Ramta Solutions. Today we are deriving the cosine rule, right? So being given triangle ABC and further information that side AB is equal to small caps C, side BC is equal to small caps A, and side AC is equal to small caps B. Let us try to find your cosine rule. So without any waste of time, when you when you want to find your cosine rule, first thing first, just like you did with your sine rule, draw a perpendicular height h. Okay, draw a perpendicular height h. Okay, draw perpendicular height h from, let's say, from vertex B. Okay, let's say from vertex B to line AC, right? To line AC, to line AC, right? So here is your perpendicular height, right? Perpendicular height h. So what I want to do, I want to change this B here. Let me call this point, let me call this point here, let me call it point D. Okay, let me call it point D. Okay, let me use a black color. Let me call it point D. Okay, now I want you to remember we have said that side AC was D. Now if side AC is D, is B, not D. If side AC is B, how about we call this one here side, let's call this one here, let's call it side D maybe. Let's call it side D. And if this one is side D, obviously this one here will be side B minus D, right? It'll be side B minus D, right? It'll be side B minus D. Okay, so we have two triangles ABD and triangle CBD. Okay, so let's look at this information. Now we're going to look at triangle ABD. Okay, let's look at triangle ABD. So in triangle ABD, it is this triangle here, right? In this triangle, as you can see, we can use Pythagoras theorem, where we say c squared is equal to, what is this, h squared plus d squared. All right, it is equal to h squared plus d squared. All right, so let's call this one here equation 1. Okay, let's call it equation 1. Now we will now look at triangle CBD, this one here. Okay, I'm going to look at it in the next page. So it'll be triangle CBD. Right, so in triangle CBD, this is CBD. So in triangle CBD, we will still say, what is our hypotenuse? It is a squared. So it is a squared equals h squared plus b minus d all squared. Right, h squared plus b minus d all squared. Right, so this is your equation 2. Okay, this is your equation 2. So equation 1 had something to do with h squared. If you remember, it was c squared equals h squared plus d squared. So let's make equation 3 from equation 1. So we will say this is h squared equals c squared minus d squared. This is equation 3 from equation 1. So basically we are solving simultaneously. Okay, so substituting 3 into equation 2, we will get a squared equals c squared minus d squared plus b minus d all squared. Now continuing, a squared equals c squared minus d squared plus this part here, when it's broken down, it'll be b squared minus 2bd plus d squared, okay, plus d squared. Okay, now let's further simplify it. We will have, we will have c squared plus b squared, the d's are cancelling, minus 2bd. Now remember, when we started with this diagram, we didn't have point D and we also didn't have perpendicular height h, so we don't want to be using point D in any way, but there is a way that we can find point D. Okay, there is a way that we can find point D. Okay, so to find point D, we can use, or rather to eliminate side D, we can use maybe cosine, right? We can maybe use cosine and see if we can find its relationship in any way. So if we use cosine, we will use these two sides, the adjacent side and the hypotenuse, right? So let's get it. Okay, so we'll say, but cos angle A is equal to D over C. Therefore, D is equal to C cos angle A. Okay, here is it. D is equal to C cos angle A. So here we will substitute this. So we will therefore say, therefore A squared is equal to C squared plus B squared minus 2b. Now in place of D, what do we put? We put C cos A. C cos A, right? 2 cos angle A. So what are we saying? We basically say A squared equals B squared plus C squared minus 2bc cos angle A. So this is your cosine rule. You can do the same to derive for b squared, for c squared, likewise. Okay, so this is your cosine rule. This is how you use your cosine rule. So I will say, generally, when you do the same thing that I just did, so generally we will say a squared equals b squared plus c squared minus 2bc cos angle A. Can you see it? It was like that. Or, okay, or b squared equals a squared plus c squared minus 2ac cos angle B. Then c squared equals a squared plus b squared minus 2ab cos angle C. So this is your cosine rule. Okay, so this is your cosine rule. Okay, this is your cosine rule for triangle ABC. Okay, for triangle ABC. So use your cosine rule when you have two angles and an included side. When, I think there are two conditions here. One, when you have two sides and an included angle. When you have two sides and an included angle, okay, two sides and an included angle, or when you are given all sides when you are given all sides. When you are given all sides, you can use the cosine rule to find either any of the angle. Okay, so basically cosine rule works when you have side angle side, remember, two sides and an included angle, and it also works when you have all sides and you will be asked to find any angle. Okay, so let me show you what we mean. So let's say you have this two, I'm going to use a red color. Let me say you have this triangle here. I'm going to call it A. Okay, let me call it A, B, C. If you are given this angle here, you must be given this side and this side, and the question must ask you to find this side. This is two sides and an included angle. Okay, this is two sides and an included angle. Okay, or you must be given this A, B, C. So you must be given all sides, and you can find either of the angles. Okay, or you must be given all sides. When given all sides, you can find either of the angles. So what do you do when you find either of the angles? It's basically to say you will be solving for the angle where you will end up using cos to the minus 1. Okay, so this is it, guys, and this is how you use your cosine rule. So this is it, and it's a wrap. So see you next time when we do examples. So bye bye.